Okay, today we're going to be going over Chapter 7, Preparing Intravenous Medications. We will actually go over this in two separate recordings. The first recording will be Section 7.1, be the first recording. And the second recording will be Section 7.2 and 7.3. Both of these will be in the second recording together. And then your 7.4 we will not cover. So here are presentation topics, percentage and ratio strength, IV flow rates, drop sets and infusion rates, and then just remember we won't be doing the 7.4. So here are your learning objectives. I can let you guys read through those. It is on your PowerPoints. So a solution, of course, is a mixture of two or more substances, gas, liquid, or solids, and of course the solutions may exist in any of the three states of matter. So a solution, of course, can exist in the following combinations. Two liquids. An example of two liquids mixed together is like a mixed drink. A gas in a liquid. An example of that one is your soda water. A solid in a liquid would be, an example would be salt water. And another solid in a solid would be like an example of fruit in a gelatin in jelly. Those to give you some examples. And of course, the definitions of solution is a mixture of two or more substances. The definition of solute is the substance dissolved in the liquid, solvent in a solutions, and a solvent is the liquid that dissolves the solute in a solution. So when preparing pharmaceutical solutions, the goal is to mix, of course, concentrations that result in accurately measured doses. So when comparing two solutions with the same components, the solution containing the smaller amount of solute is considered the dilute. The solution containing the larger amount of solute is considered the concentrated part. The concentration of one substance dissolved in another substance may be expressed as either a percentage or a ratio strength. So how the concentration of a solute in the solvent is expressed as a percentage depends on which is a solid and or which is a liquid. So the concentrations can be expressed as fractions, and it can be with weight. One example of that, of course, I think I give it to you in your next few slides, is WW, which means weight of a product, which could be like X grams of a drug. Okay, and another weight would be the product, 100 grams of the product. Okay, previously we've been doing weight and volume. So weight and volume, your example for weight may be like X grams of the drug and the milliliters maybe of the product. Okay, and then we'll also do volume and volume, which would mean X milliliters of a drug over X milliliters of product. And so this gives you the definitions of those that I just went over. So right here we have an example of a 9% solution means there are 9 parts of the drug in 100 parts. And remember, percent always refers to 100 parts. So that's where you get your 9 from the number 9 of the drug in 100 parts. So the percentage is the 100 parts. Okay, you can express that in either weight and weight, weight and volume, or volume and volume, which we give you here. Again, weight and weight. So you have grams and grams, or you have weight and volume, grams and milliliters, or you can have milliliters and milliliters. So an example of that would be if you was to express like 1% of hydrocortisone cream as a weight and weight, 1% hydrocortisone cream would be 1 gram of the drug of hydrocortisone cream and 100 grams of the product, or the final product. Hold on, I'm sorry, I have to pause for just a moment because my computer froze up. Okay, sorry about that. Thank you. My computer sometimes will freeze up and I cannot turn to the next section, so I have to do the task manager and take it off and then put it back on. So I have to pause the recording, so I apologize for that. But there's some important ratios to remember, and that's of course when setting up problems involving solutions. Of course, a percentage of a weight in weight solution equals gram of an active ingredient over the 100 grams of your final product times 100. So remember, your weight and weight solutions involve mixing two solids such as a dry powder and a cream. So your percentage strength of your weight and volume is going to equal X grams, of course, of an active ingredient over 100 milliliters of a solution times 100. So remember, your weight and volume involve adding a solid drug to a liquid such as a powder dissolved in a syrup. And of course, your last one here, you have, of course, your percentage strength of your volume and volume is going to be milliliters of active ingredient over 100 milliliters of solution. You're going to multiply that by 100. An example of your volume and volume are going to involve mixing a pure liquid and another liquid such as pure alcohol or water. So what does the abbreviation NS stand for? So that's going to stand for normal saline. So we'll talk about that some within these word problems. So your intravenous solutions, of course, that are given in large quantities are labeled as percentage strength, such as dextrose 5%, which is also written as D5W. Okay. So if you look here, you'll see your 5% dextrose injection. And that's usually written, like I said earlier, D5W. Okay. So, and then this one down here is your normal saline, which is, normal saline is always 0.9% sodium chloride, and it's just in the injection form. So, your normal saline is a solution of water and sodium chloride at 0.9% concentration. So, this kind of gives you some example labels to look at. So if the percentage of concentration is known, it can be used to find the amount of the active ingredient. So here's an example, or some things to remember. How many grams of dextrose are in 1 liter of D5W? So first you want to note that the D5W means 5%. And remember, when you have a percent, it's 100 dextrose in water. So we know it's going to be milliliters. So it's going to be a weight and volume. Or you can just say 5 grams in 100 milliliters. And you also want to remember, because we're working in milliliters, when we do any problems, sometimes it'll give you, in the word problem, it'll give it to you in liters. But if we're working with milliliters, we need to convert that 1 liter over to milliliters. So that's what we did. 1 liter is going to be equal to 1,000 milliliters. So if you can sometimes you can set these up as ratio proportions, and then sometimes you can set them up as dimensional analysis. And I always tell students, just do whatever is easiest for you. With these, I go back and forth. I read through the word problem a couple times, and then whatever I find would be the easiest, I do. Usually I find ratio and proportion the easiest, because if you know your 3 parts, you can, of course, find a third. So we know we have X grams, okay, of dextrose in 1 liter. And then we'll go ahead and put it down like that. And then you have your 5 dextrose 5% in water, so it's 5%. So you have 5 grams in, percent is always 100, and it's always milliliters. Okay. So next, what you want to do is you have your weights on the top, and you have your liquids on the bottom together. So you want to make sure that they all match. So the 2 units on the top match. but the units on the liquid units do not match. So we want to convert your 1 liter over to milliliters. So it'll be 1,000 milliliters. You're going to cross multiply. X times 100 is on the bottom, it'd be 100. 5 times 1,000 would be 5,000. Okay, then if you mark out your 2 zeros, then you got 50 divided by 1. So your X grams is going to be 50. Okay. So there it is, worked out that way. So the percentage of solid solute in a solution is expressed in grams per milliliter. So your percentage of weight and volume solution, you have grams of solute over milliliters of solution times 100. So in this example, if there are 30 grams of dextrose in 5 milliliters of solution, what is the percentage of the solution? So this one can be done, 2 different ways. So the first one, you can solve the equation by just doing the weight and volume. You have 30 grams in 500 milliliters. You could do that and just divide 30 by 500, multiply it by 100, and you should come up with 0.06 times 100 equals 6%. Okay. Or, I just like to stick with ratio proportions as much as I can. You can do it that way. So you have 30 milligrams in 500 milliliters. You're trying to find X percentage. Okay, so when you have a percentage, it's always the percent sign is 100 milliliters. Okay, so we have that. So we need to find the X grams. So we have our 3 parts. So then if you cross multiply, you come up with X times 500 would be 500. 30 times 100 would be 3,000. Again, mark out your zeros. That'll help. 30 divided by 5 is 6%. Or you could say it's 6 grams. Okay. Again, this is do which way is easiest for you. Again, I like to set it in ratio proportion, but you got to be careful because when you set it in ratio proportions, you have to always remember to make sure that the units on the top are the same, the units on the bottom are the same. Okay, so if you look at this problem here, this is number 8 out of your book, and it is on page 182. And it says at the top of number 7, and it goes with 7, 8, 9, I think 10 through 14. So it says calculate the percentage strength of drug in the following drug formulations. So you're using that label to find what you're looking for. So you could do it with the 40 milligrams per 4 milliliter. And you're trying to calculate the percentage strength. Remember, the percentage strength is always in grams over milliliters. So the strength would be in grams. So you're trying to find X grams. So if you look here, you multiply it by 100. So on this one I'll do both, but on the other ones I'm just going to do what I like to do, which one I like to do better. But this is in milligrams, not grams, and in our question it says calculate the percentage strength, and percentage strengths are always grams. Okay, so you got to take your 40 milligrams and convert it to grams. So that would be 0.04 grams. Take that, divide it by 4, multiply it by 100, which is, of course, if you take 0.404, divide it by 4, and you get 0.01. Times that by 100, and it comes up to be 1. Okay. Doing it the ratio proportion way, we know we have 40 milligrams per 4 milliliters. We know we're trying to find by the question calculate the percentage strength. So that's going to be X grams, and it's a percentage, so it'd be 100 milliliters. Okay, both units on the bottom are the same. Both units on the top are weights, but they're not the same, so we need to convert it to make it the same. So 40 milligram again is 0.04 grams. Okay, then you're going to cross multiply. 0.04 times 100 is 4. 4x would be on the bottom, divide it, and you would come up with 1. So it's what you could say 1% or 1 gram of your weight in volume. Okay, now for problem number 9, which is on same page, or it's actually on page 183. Okay, so we're going to do the same thing. We're going to calculate the percentage strength of a drug in the following drug formulations using this label. So we know we have our 60 milligrams per 2 milliliters. We're trying to find X grams because it's calculate the percentage, and the percentage is 100 milliliters. So we know our units on the bottom are milliliters, units on the top are weights, but they're not the same. Convert 60 milligrams over to grams, and it will be 0.06 grams. Okay, cross multiply. X always goes on the bottom, so 2 times X is 2. I always put X if it just helps you to do that. And then 0.06 times 100 would be 6. 6 divided by 2 would be 3%. Or you could have said 3 grams. Okay, next, another example, number 11. Again, this is on page 183. And then we're doing the same thing. We're going to calculate the percent. So you know you have X grams over 100 because you're milliliters. Because percent means 100. I'm trying to find the percentage strength, with the strength would be in grams. Okay, so you look at your label and you have 400 milligrams in 40 milliliters. Again, milliliters, those match good. Grams, milligrams, or they do not match, so you got to convert to match. So 400 milligrams is equal to 0.4 grams. You're going to cross multiply. Whatever you multiply the X by goes on the bottom. So 40 times X will be 40. 0.4 times 100 would be 40. And it will equal out to be 1%, or you could have said 1 gram. Okay, again, this is number 14. Again, we're doing the same thing. So you have your X grams, because we're calculating the percentage strength. So percentage would be 100 milliliters. Look in our label, and we have, of course, 20 milligrams per milliliter. If it says just milliliter, it means 1, so 1 milliliter. Again, the bottom units are the same, milliliters. Top units are weights, but they're not the same unit. So you need to convert the 20 milligrams over to grams. So 20 milligrams would be equal to 0.02 grams. Okay. Then you want to cross multiply. X times 1 would be 1x. 0.02 times 100 would be 2. 2 divided by 1 would be 2, which would lead your answer to be 2% or 2 grams. Okay, now we'll veer off from the labels and we'll go to page 183 and we'll do number 15, excuse me. So number 15 is on page 183. So what you need to do is you need to calculate the amount of drug in milligrams for the following dispensed containers. And then number 15 says is the teroconazole 0.8%, 20 grams. Okay, so we have our three parts, 0.8%, so our percent would be our 100, so we have our three numbers. So we have 0.8%, which would be grams, and their percent would be 100 milliliters. Trying to find X grams. Well, actually, we're looking for X, calculate the amount of the drug in milligrams. So you'll be X milligrams. Okay, so X milligrams over 20 grams. Okay. So what you want to do first, if you went ahead and made a mistake and started converting, I wanted to show you guys how to do that. This is grams. Oh, sorry, this is weight and weight. I apologize. So this is supposed to be 0.8 grams over 100 grams, and you have X milligrams over 20 grams. So the units on the bottom should be grams. Both units on top should be milligrams because it's asking for the number of milligrams. But I'm going to go ahead and work it out and show you how you can convert at the end as well. Okay. So what you need to do is you just cross multiply. Instead of converting first, I'm going to convert at the end. Okay, just in case you was to work a problem out and forget. So 100 times X would be 100, and it goes on the bottom. 0.8 times 20 would be 16. Okay, and then you turn out to be 0.16 grams. So then if you get to the end and you're like, oh man, it's supposed to be, calculate the amount of drug in milligrams, not grams. What you need to do is you just take that answer there and you can convert it over to milligrams. So you take 0.16 grams. You have grams here, you need to have grams here. And then, of course, 1,000 milligrams is equal to 1 gram. So you take the 0.16 times 1,000, it's going to be 160 milligrams. Divided by 1, which gives your answer 160 milligrams. So your answer is in milligrams now. Okay, so you can convert at the end if you forget. I usually find it easier to convert at the beginning, but it's up to you what you would rather do. Do what's easiest for you. Okay, next we're going to do number 16. Again, I'll do the conversions at the beginning versus at the end, just to kind of give you another way to look at it. But calculate the amount of the drug in milligrams. So we're going to have X milligrams. Okay, so that's what we're trying to find for the following dispense containers. So number 16 is your benzoyl peroxide, 10%, and it's in 30 gram cream. So we're doing weight and weights. Okay, so you have your percentage, which would be 10 grams over 100 grams. Because 10%, 10 grams, and it's going to be 100 because it's weight and weight, so it'll be grams. Over here, we're going to do, and then it says of a 30 gram tube, so 30 gram. So we have the units the same on the bottom, and we have the units the same, not the same on the top, so we have milligrams and grams. So what you want to do is convert your 10 grams to milligrams. And that would equal out to be, you just multiply that by 1,000, and that would be 10,000 milligrams. So now we have our units the same on top. So then you're going to cross multiply, and X times 100 is 100, and it goes on the bottom. 30 times 10,000. 1, 2, 3, 4, 5. You have 300,000. Okay, so what you want to do next, if you want to simplify it, you can take out the 0 here, take out a 0 here, take one out here, take one off here. So then you're left with 3,000 divided by 1, so it'll be 3,000 milligrams. But you could have converted at the end if you wanted to as well. Okay, I will do one last problem. We'll do number 17. And again, 17 is you, calculate the amount of the drug in milligrams for the following dispense containers. You have your drug as 0.77%. So 0.77 grams over 100 grams, because you have your strength as 0.77. It is a percentage, so it'd be 100 grams underneath. Okay, and then that's out of 45 gram. So we're trying to find it in X milligrams. Okay, so if you look here, of course you have your 100, your grams and grams on the bottom to match, but you have milligrams here and grams here. So next, and I'll just show you how we convert if you have forgotten. If we want to take our grams and convert it to milligrams, we just put 0.77 grams here, nothing goes here. 1 gram equals 1,000 milligrams, and that's where you just multiply it by. So if you went in your calculator, put 0.77 times, of course, 1,000 would be 770. Okay, so this would be 770 milligrams. So we've already done our conversions. Then we're going to cross multiply. 100 times x is 100, and it multiplied by the x, so it always goes on the bottom. Then your 770 times 45 would be 34,650. And you want to divide that by 100, and your answer should come out to be 346.5. My 5 won't go on there, but that's supposed to be 346.5. Okay, so there it goes. So you can have that as x in milligrams. So that's what you're trying to find. Okay. So what would be best is practice makes perfect with calculations. So I would go through page 1A2 and 1A3 and work through 7.1 problem set. Okay. If you run into any problems on it, if you get stuck on any of them, just let me know. I'll be glad to set up a time for you to come to my office so we can meet and I can go over it with you. Okay. And the rest, 7.2 and 7.3, will be on the next recording. Thank you.